today we're going to start talking about exponential functions and their graphs. So I think this will be a pretty simple lesson, especially the ones where you're plugging in numbers. So an exponential function f with a base of a is denoted by f of x equals a to the x. So exponential functions have an x in the exponent part, which kind of makes sense, right? Where a is bigger than 0, so in other words, your base is not 0 to something, right? It would be like 1, 2, 3, 4. And a does not equal 1. Okay, so in other words, a is bigger than 1. And x is any real number, okay? So first off, we're just going to kind of have a little reminder of how to plug into an exponent, which we kind of all know already. But they're telling us that our value of x is negative 3.1. So we're just going to take this equation and plug in negative 3.1 for the x. So I literally would just take my calculator and plug that in. So 2 to the negative 3.1. 2 to the negative 3.1. And that gives me 0.11. Let's just, we'll just round to the third one over. So 0.117. So f of negative 3.1 is equal to 0.117. So we all kind of remember how to do that, right? Or pi. So this would be 2 to the negative pi. So I have 2. Remember the caret right here is where you raise it. To the negative, and then your pi symbol is right here above the caret. So second caret, enter, and we get 0.113. So it'd say f of pi is equal to 0.113. And really we should be using the approximate instead of an equals. Okay, I'm not even going to do the last two because I feel like that you guys are good with that. Okay, so when we're graphing, it's always good to look at it on your calculator. I mean, I'm all for, you know, usually on a test like the ACT or something, they're just going to ask you to match the graph, right? You don't ever have to draw a graph. So I like for you to be able to plug into your calculator and analyze those kind of things. But I think that graphing them by hand also helps you learn to analyze them. So we're graphing both of these on the same graph, so you might want to use 2 different colors or like a pen and a pencil so that you kind of know. I'll just use 2 different colors today. So let's start with the first one, f of x equals 2 to the x. So we're going to make a table of values. So on your calculator, I know we've got some stuff in the y equals. So if you have an equation here, take that out. But also we've turned on our plot because we plotted some points the other day, so we need to go up and turn that off because we don't really care. Okay? And I'm going to put that equation in, which was 2 to the x. So 2 to the, and then remember your x is right here next to the green button. All right, so we have 2 to the x, and also it's not going to be centered for us because if I don't press the graph, but if you look, like my graph is way off somewhere else, right? So to get back to the center, you're just going to press zoom and then 6 for your standard window. And that should bring you back here. And you can see your equation, right? So what I like to do is I like to look at a couple of different things. Notice that this flattens out. Now it looks like it's touching the x-axis. It's really not. It's just gotten really, really close. And I like to look at about where it does that. Okay, so if I'm looking at this right here, once I get to -3, I'm like almost touching, correct? So probably as far over as I would want to graph would be at about -2. So maybe I would do -2, -1. I cross at 1 on the x-axis, right? And then I might want to do 1, 2, maybe 3, but see how if I pick an x value of 3, I'm going to be way up there, right? But you eventually get to a point where, like, if I picked an x value of 4, that's going to be off my graph, right? That's going to be way up here. And so I only want to pick the stuff that's going to fit onto the coordinate plane I'm graphing on. Okay? So if you don't have the graph and the table on one thing, you're just going to go to Mode, and then you'll come down here where it says Full Horizontal Graph Table, and you're going to choose Graph Table. That way it puts it side by side. So mine is already set up where I can pick my own values, right? But to access the table, I still have to choose Table. So I'm going to go Second, Table. All right? And I'm going to start with an x value of -2. So if I pick -2, and when I do that it jumps down, so it looks like it's right here, but it's really not. All right, when I pick -2, that gives me a y value of 0.25. I would at least like for you to be that low to your x-axis, okay? Any lower than that, you really don't have to be. I mean, I could choose to do -3. That gets me really close, okay? So I'm going to start with -2, and then I'm going to choose -1, 0, 1, 2, 3. But if I pick an x value of 4, I'm way off my graph, right? So these are the only ones that really fit onto my graph. I could pick more this direction, but it's going to be so close to the x-axis that it's kind of pointless. So this is my table of values. So you can mark that down on your table that you've put in your notes. That way you kind of know where you got those numbers there. So we've got -2, 0.25, -1, 0.5, 0, 1, 1, 2, 2, 4, 3, 8, and then 4 was going to be off the graph, right? So I'm going to go ahead and plot these points over here. So I have -2, 0.25, -1, 0.5, 0, 1, 1, 2, 2, 4, and 3, 8. So now when you draw this, this gets really close to the x-axis, but it never actually touches or crosses, right? So what I like to do is, my point right there is a little bit high. Okay, what I like to do is I like to start kind of a little bit in front of that dot, and then I'm going to follow all the way up, and you want to extend, and then you'll put an arrow on each end. Just make sure that you don't cross the x-axis right here. This does not cross. Okay, no crossing the x-axis. All right, let's do the other equation. So we have a g of x. I'm going to use my other color. Equals 4 to the x. And again, we're going to make a table of values, but we're going to use our calculator to help us with that. Go to your graph. So you need to go to your y equals and change that equation. So this time it's 4 to the x, right? So just change that to a 4. You don't have to change anything else. And then go back to your graph so you can take a look at it. So if you look at this graph, one difference is that it gets lower faster on the left, right? And again, it looks like it's going to touch and cross that x-axis, but it's not, okay? It's just that blue line is really thick. So maybe I I probably only want to go over as far as -1. I think -2 would probably be too far, because if you look right here, see how when you plug in -2, you get 0.06, which is almost 0, right? So 0.25, I'm good with that being the lowest that you have to go. So we'll start with -1 on this one. But notice that this one gets steeper faster. So once I hit an x value of 1, I'm at 4, but then all of a sudden at 2, I'm at 16. So we can't pick as many points on this one because they'll be off of our graph. So I'm really only going to choose -1, 0, and 1. So -1 is 0.25. 0, 1. So still crossing at the same place. 1, 4. And I really don't like 4 being the highest that we go up, so maybe let's try and plug in a decimal and see what we get. So, oops, go back to my table. You got to press table or it knocks you off. All right, let's try 1.5. 2 was too high. Okay, so if we choose 1.5, we get an x value of 8, and I like that, so we'll go up to 1.5 with an x value of 8, or y value of 8. So -1, 0.25, 0, 1, 1, 4, and then 1.5, 8. And then you'll do the same thing that we just did. Make sure you put arrows on both ends, but that you do not cross your x-axis, or touch it really. All right, so let's take a look at number 2. So I'm going to start with the f of x is equal to 2 to the -x. So now our exponent is negative. We're going to see how that changes our graph. So when we have that positive x, we know that it starts low and then goes up high. And we'll see what happens when we change that negative right there in the exponent. So I'm going to go to my calculator and put in the 2 to the -x. So 2 to the -x. And I'm going to go ahead and go to my graph. All right. So when we have that -x in the exponent, it actually flips it around, right? Instead of going low to high, it goes high to low. So if you're looking, probably the farthest left you would want to go is maybe -3, probably not -4. I think that's going to be way off the graph, but we'll try it anyways. And the farthest to the right, we're starting to flatten out here at 2, so I'm thinking that's probably the farthest to the right that you want to go. So I'm going to access my table by pressing second graph. Let's try -4 and see. Okay, -4, you get a y value of 16. That's way too big. So we'll start with -3. That's on our graph. So -2, -1, 0, 1, and 2. And remember, I want you to at least go down as far as 0.25. Now, are you always going to have a 0.25? No, but I don't want you to be any higher than that. So you would need, I mean, if you have like a 0.2 or a 0.15, that's fine. Just make sure that you get close enough to where your graph is going to be accurate. All right, so go ahead and fill your table in on your paper. So -3, 8, -2, 4, -1, 2, 0, 1, 1.5, 2, make sure I get that right, 0.25. And then just go ahead and plot those points. So -3, 8, negative 2, 4, negative 1, 2, 0, 1, 1, 1/2, and 0.25. So now let's do the g of x one. So if you're using the same kind of principle as what happened last time when we changed that base to a 4, this should be a lot more steep, right, than the last one. So change that base to a 4. You don't change anything other than just the 4. Okay, so again, it is steep. Now, negative 3, way too big for the x, right? Or like way off the graph. So we might want to do what we did last time and choose negative 1.5 since negative 2 is too big. And that works out really well. I'm going to go ahead and just fill these in. 0, 1. Now, at 1, I'm already at 0.25, right? So I really don't need to go any farther than that. So I'm going to go with the negative 1.5, the negative 101, which would give me the 841 and the 0.25. So negative 1.58, negative 1, 4, 0, 1, 1.25. That was a really crappy looking graph. Okay, so now let's talk about the natural base e. Remember, e is an actual number, okay? And it is located right above the division sign in blue. It's this little e right here. So if I press the second and the division key, I get the e. And this is the value of e. Okay, e is not a variable. E is a number, kind of like pi is a number. All right, so this is the value of e. And so we're just going to practice just for a second plugging this in. So if I have e to the x, if I did e to the negative 2, I would literally just take my e, which is second division, and raise that to negative 2. There's another place where you can access the e, though. If you know you want to exponent, you don't have to press the caret. Over here above the ln, which is your natural log, there's an e to the x. So if you know you're going to use an exponent, you can press the second button in that, and then it already gives you the box up there. But if you don't have an exponent, then you just use this one. You can use either one. Or if you don't need the box, then you can press delete. Okay? So that's just another way to access that. So we got 0.135. So f of negative 2 is equal to 0.135. All right, and we're not going to do the rest of these because I'm fairly certain that you guys can plug a number into the calculator. All right, so number 5, we're going to graph some of the natural base equations. So let's start with that f of x. So 2e to the 0.24x. It's a little blurry, but that's what that is. So 2e to the 0.24x. So I'm going to clear that out. 2e to the 0.24x. So these are very similar, right, to the exponential functions. And that's because x's in the exponent, right? Just has a natural base. So if you're looking at this, I don't want to stop at -2 because I'm not low enough. 3, 4, 5, maybe at -6. So let's see what that is when I plug in -6. Oops. I'm forever not choosing my table. All right, -6. I'm almost to a half, so that's too tall, right? So let's try -7. Okay, -8. Okay, let's go with the -8. We'll go all the way to -8 on the left. And here's the thing. You don't have to pick every single number over here. So maybe if you wanted to do like -8 and then maybe -5 and then maybe -2 and then 0, because you don't need to pick every single one, right? You just need enough points to where you can connect them, you know, and make a good graph. So I'm going to maybe do -8 and then maybe jump to -5 and then -2 and then 0 and then maybe 2, 4, 6, 8. Okay, 8's too high up, right? So I might want to do 7. Let's see. Okay, we could do 7. So I think that's what I'm going to do. And you don't have to graph every single one of these points. Okay, and they're not going to be perfect, right? Like if I graph 1.2, I mean, it's going to be in the general area, but it won't be perfect. So go ahead, fill in your table. So once you plot your points, and you can see if you've got one a little too high, then it won't be, you know, a nice curve. See if I can make this look decent. And then make sure you put your arrows on each end. Now let's say that you don't pick enough points, right? You can always go back. Like if I felt like I needed one between these two because they're kind of far apart, I could always go back and pick 6, right? Which should put me up here somewhere. I mean, skip around, and if you need more, then go back to your table and pick another number to plug in, okay? Your table doesn't have to go in order. It's really just a guide to help you plot your points. Okay, we're not going to plug in the second one. I think that we're good there. Okay, so let's talk about formulas. So compounding interest, we've got 2 formulas for that. Okay, this formula up here is for when we're compounding that interest so many times per year. Okay, so if I said we were compounding quarterly, that would be 4 times a year, right? We would break that up into quarters, like think about $1 in quarters 4 times a year. Or if I said biannually, that would be twice a year, right? Or semi-annually, right? Because lots of stores have semi-annual sales. All right. This is for continuous compounding interest, also known as PERT, because it's P times E to the RT. So the T represents the years. A represents how much money you have in your account at any given time. P represents principal, which is your original amount, and your annual interest rate in decimal form. So if I said 5% interest, I would have to take the decimal and move it 2 places here, right? And 0.05 would be what I would plug in for my rate. Okay, you will not plug, if I say 5%, don't plug a 5 in for the rate. You would plug in 0.05. All right, and so you have these 2 formulas. So they will tell you with the words which one you should be using, okay? So we have a total of $9,000 that's invested at an annual interest rate of 2.5%. So I'm going to go ahead and change that to a decimal by moving that decimal place 2 points to the right, which means I have 0.025 is what I'm going to plug into my formula. And that represents my rate, right? Compounded annually. So if I said I'm going to compound something annually, that just means one time, right? Okay, so n would be 1. We're going to find the balance in the account after 5 years. So t would be your 5. And then your original amount of money is $9,000. So that represents your P. I kind of like to pick out that stuff as I'm reading it. All right? So since I'm compounding so many times per year, since it said annually, it didn't say continuous, right? Then I'm going to use this formula right here. So I want to know how much money I have. If I start with 9,000, so that goes in for the P. And then 1 plus my rate is going to go on top, so 0.025 over how many times I'm compounding, which in this case is 1. And then I'm going to raise that to n times t. Well, n is 1 and t is 5. And you're literally just going to plug this in your calculator as it looks. So I've got 9,000 times 1 plus, get a fraction, 0.025 over 1, which I really don't need the 1 there, but we're going to keep it. And then I'm going to raise that to the 1 times 5. You just want to make sure that you get all of your numbers correctly in here. So it literally looks exactly like it is on our paper, right? Press enter. And this is money, so we always round to 2 decimal places. So we have $10,182.67. And again, this is money. So $10,182.67. So if you think about this, in 5 years, how much money did this person make? They started with 9,000, right? After 5 years, they now have $10,182.67, so they made $1,182.67, which doesn't seem like very much after 5 years. Okay, number 7. A total of $12,000 is invested. Okay, so that would represent what part of our equation? P. So P is 12,000. I'm just going to make a list. Is invested at an annual interest rate of 3%. So my rate would be 0.03, right? Because if I take the 3, move it, that's going to give me a 10 in front of that. Find the balance after 4 years, so time would be 4 years. When the interest is compounded, okay, we've got 2 questions here. First, it would be quarterly, which means how many times? 4. But then the second time we're going to do it with the other equation, right, for continuously. So I'm going to plug in. I've got 12,000. So this would be part A. Got 12,000 times 1 plus, going to take my rate, put that on top, and then put how many times I'm compounding on the bottom. And then up here, it's how many times you compound times how many years you're compounding. All right, so if you plug this in, I'm just going to tell you that you will get $13,523.90. And yes, you need to put the 0 because it's money, right? By the way, I'm going to point this out too. In this equation, this 1 represents 100% of what you have plus this. If you were like losing money, then you would take away. Okay, so it's kind of the same thing, but we're investing, and apparently that's not risky. All right, so for part B, we don't need how many times we're compounding, right? Because we're going to be using the P times E to the RT. So we literally start with your principal, which is 12,000, times E. Remember, E is an actual number, so we don't plug in for E. And then we're going to raise that to our rate and the time. So the rate would be 0.03 times our time, which is 4, and we're literally just going to plug that in. So we have 12,000, and then I'm going to get the E that has the exponent, which is second natural log, and then 0.03 times 4. And we get 13,529.96. 13,000, what did I say? 529.96. So which was a better deal for him? So the compounding continuously, was it a big enough deal to really matter? This is 13,523. This is 13,529. I mean, literally like a $6 difference, right? Okay, number 8. The approximate number of fruit flies in an experimental population after T hours is given by this equation where T is greater than or equal to 0. So you can't have a time amount that's smaller than 0, correct? So we're going to find the initial number of fruit flies. Well, how do you know how many fruit flies you had in the beginning? What amount of time would have passed in the very beginning of an experiment? No time, right? Like my initial number of fruit flies that I have is when time has not moved, okay? So I'm going to plug in 0. So I would have 20 times e to the 0.03 times 0. All right, so if we plug that in, 20 times e to the 0.03 times 0. So initially we had 20 flies. All right, it says, how large is the population of fruit flies after 72 hours? What are you going to do with this 72? T represents time. So where does the 72 go? With the T, right? So I would have 20 times e to the 0.03 times 72 hours. So grab my calculator. Instead of putting a 0 up there, I need 72. So at the end we have 100, and we're just going to round this, so 173 fruit flies. Man, that's a lot of flies. And we're not going to graph part, we're not going to graph it. All right, 9. Let Y represent a mass in grams of radioactive strontium, all right, whose half-life is about 29 years. The quantity of strontium present after T years is Y equals 10 times 1/2 to the T divided by 29. What is the initial mass? Okay, anytime they ask for the initial, that's when you have not had any time pass, right? What's the initial amount of flies? What's the initial amount of money? What's the initial? That's when T is 0. So for part A, we're going to plug in 0. So we have 10 times 1/2. And you know I don't like slashes for division, so we have 0 divided by 29. And you're going to get 10. And notice this is representing your mass in grams, right? So this would be grams, 10 grams. That's how much I'm starting out with. Then it wants to know how much of the initial mass is present after 80 years. So what should we do with 80? Plug it in for the time, right? So I have 10 times 1/2 to the 80 divided by 29. So 10 times 1/2 to the 80 over 29. Literally just how you've written it down. So we get 1 point, let's just say 5. So 1.5 grams.